Hi guys, welcome back. Domain tree architecture and design. So in this video we're going to see chapter 3.8, explain how resiliency and automation strategy reduce risk. So this is a topic we are going to see. We're going to discuss one by one. Let's go for the topic. Automation and scripting. Resiliency and automation strategies help mitigate organizational risk. Resilience is the organization's capacity to continue acceptable level of service when disruptions to vital process or system occurs. So automation can range anywhere from basic script to automated collective action systems. It includes functions such as courses of actions, continuous monitoring, and configuration validations. Automation greatly increases an organizational capability to detect and respond to threat. Automation systems or frameworks are used for course of action that require 5 important things. So first one is a characteristic of interoperability, extensibility, and industry standard based. Second is a built-in privacy protection from the ground up. Third is a based on international technical standard. Fourth is capabilities to deal with system attack attempts. Fifth is a capability to effectively identify false positive. These types of system combines machine learning with the automations to respond to a threat and maintain critical operations. Automated collections systems are meant to be resilient and more secure because devices work together in near real time to anticipate and prevent attacks. This system can be considered an extension of continuous monitoring, which the next sections we will talk about this. Organizations have an option to automate individuals area as part of holistic approach to automation. For example, an organization can automate on infrastructure build out to reduce the chance of security mistakes and can include automated system monitor in system deployment as part of the configuration process. So on a smaller scale, organization can use scripting and vendor provide tools for automated courses of actions such as security and network tasks. Automation scripts for management and provisionings are done through command line interface and APIs. Automated configurations and provision capabilities are already built into device from most major vendors. For example, Cisco iOS software provide embedded automation capabilities. So Windows PowerShell scripting is used to automate Windows administrations and security tasks. The purpose of continuous monitoring is to ensure that the processes are followed and enforced so that they detect organizational compliance and risk. In certain instances, such as to comply with the industry regulations, continuous monitoring is required. For example, PCI DSS compliance require that an organizations have a well-defined process in place to review and reassess security practice even in highly dynamic business environment. So it took often provide script to help with the continuous monitoring. For example, SolarWinds maintains more than 100 predefined automation scripts in its scripting library. So PowerShell can be used to implement continuous monitoring as well. So configurations validation for organization can be done through the security content automation protocol developed by NIST to enable automations, vulnerability management, and policy compliance. Configuration assessment as a service is a method developed within the European Union for automation validation and assessment of configuration settings over distributed environments configuration. The configuration validation scripts can be written depending on the target, and PowerShell can be used for configuration validation as well. For Windows machine, the security configuration and analyze snap-in works to validate configuration. So additionally, the script language such as Python can be used either alone or in combination with other script or tools. For example, Cisco DevNet has readily available script that leverage Cisco provided Python library for device automations. Let's move on next slide. Frameworks and templates. So for frameworks, you can see in the previous chapter 3.1, we were discussed this topics: NIST, ISO, PCI, DSS. So you guys discuss. So you guys go and watch the video, and then we're going to talk about we're going to discuss the templates. So template and master image sometime. So this is security issues, that security templates are used as a basics for device configurations. Configuration settings for template can be based on industry standards or organization parameters. Templates ensures consistency in deployments and meet requirements that reduce organizational risk. A template can be based on the OS or security requirements. For example, limited access kiosk system use a template with a lower security settings than a system that is used in financial transaction. The Microsoft Security Compliance Toolkit consists a configuration baseline for different releases of Windows. Template can also be used to define standard network designs and device implementation, ranging from writing clauses to a VPN concentrator. In high-risk environment, template can contain an entire network specification that include topology, installation requirements, and device configurations for all cable, hardware, and software. So these type of template reduce the organizational risk level by providing some assurance that no additional risk is introduced through variations in equipment. Automation tools such as Chef or Puppet can be used to apply security configuration changes to template and image. A golden image. So there's a later on slides. There's a golden or master image is a template used for hard disk, virtual machine, or server. Master image are often used in a self-service provisions environment. For example, so when a new remote employee begins employment, the employee's laptop accesses the organizational networks, and the master image is downloaded to the laptop. The advantage of using a master image is that the environment is set up exactly the way it is needed and then saved. Changes are made only to the master image. These save time and provide consistency. So a master VM is typically created a virtual desktop template. So when the master VM is created, the hardware and software parameters are specified so that all created VMs in the managed virtual desktop environment have the same setting. For example, if the master VM is assigned 8 GB of RAM, then each created VM in the managed environment will be assigned 8 GB of RAM. So this makes it easy to manage hundreds or thousands of VM using a single master VM as the template. Let's move on next topics. So this is what we explain what I explained. What is a golden image, everything. So okay, so we move on the next slide. So managing cloud risk. There's a 5 important topic. So non-persistence, elasticity, scalability, distributive allocations, redundancy, high availability. Non-persistence. Temporary systems image snapshot to no good states. So meaning a persistent system is one that is generally still removable in the event of failure. For example, if a CPU dies, the system informations and data are generally recoverable when the system is restored. In a non-persistent systems, if a failure occurs, the information is lost. This is similar to what happened to the memory contents when a system is shut down. So cloud environment tend to be fluid and work differently than physical desktop environment. Persistent cloud environment tend to be more difficult to support than non-persistent environment, especially with the data storage especially with the data storage or volumes. Sometimes persistence is not desired. Non-persistent is part of the concept of elasticity. So we will talk about this next topic. So snapshot, most of you guys are aware of it. Snapshot preserve the entire states and data of the VM at the time it is taken. A snapshot includes the virtual machine settings and state of the machine's virtual drives. The contents of the virtual machine's memory can also be included in the snapshot, but it is not recommended and rarely needed. A snapshot can also use to restore point when testing software or configuration changes. When you take a snapshot of a virtual machine, a new child disk is created for each attached disk. Keep in mind that for a snapshot to work, the base disk is needed. Therefore, snapshot should not be used for backup as backup solution. Best practice for performance is to keep only 2 or 3 snapshots, and only for a short period of time. Inherent changes occurs in the VM, and the snapshot file can grow quickly, filling up space in the data store. Restoring a snapshot is often done using software automations. Although VMware is the most popular product for VMs, Microsoft also offers a virtualized solution in Hyper-V. The Microsoft Hyper-V terms for a snapshot is checkpoint. Checkpoints work the same way as snapshot in VMware, with a certain limitation. For example, they cannot be used in a VM design as an Active Directory domain service role such as domain control. Second is a scalability, elasticity, scalability. Although they are somewhat related, scalability and elasticity are two different concepts. Scalability is the capacity to expand the amount of production from the current infrastructure without negatively impacting performance. Scalability issues can cause us failure in many areas such as systems, applications, and network business. Scalability can refer to systems or software applications and can be vertical or horizontal. Vertical scalability refers to the capability to scale up within a system. Horizontal scalability refers to a scaling linearly or scaling out to the multiple system. Applications are generally built in with the capability to scale either vertical or horizontal, so that the lack of resource doesn't affect performance. The exam tips I give you that scalability can involve the capacity to decrease as well as increase service or resource. Okay, elasticity is the capacity to elasticity is the capacity to dynamically expand or reduce infrastructure resource by autonomously adjusting to workload changes to maximize resource. NIST define elasticity as the capability for rapid automation, automatic and elastic provision of resource to quickly scale out, as well as the capability to rapidly release to quickly scale in. Because elasticity is used to scale out solutions, allowing resource to dynamically added or removed, it result in infrastructure cost saving. So this is particularly useful when dealing with a virtualized environment, because host availability is concerned. With elasticity, resource can be purchased as needed based on the time frame, platform, or operating system. The main difference between elasticity and scalability has to do with the resources. So scalability is based on the capability to handle the changing needs of a system, process, or application within the confines of the current resource. Elasticity is the capability to expand and reduce resource as needed at any given point in time. Third one's distributive allocations or load balancing. So various principles determine how availability resources are distributed in a cloud environment. In a cloud environment, this is even more important, especially with elasticity. The idea behind the distributive allocations is to distribute the environment among different providers or components. Approaches to distributive allocation range from resource throttling to your federations of multiple clouds. Improper resource allocation management can allow attacks such as DOS. If an organization doesn't have the capability to recognize when a malicious resource consumption event is taking place, legitimate users will be denied access to resource. Proper resource allocation planning is key. Proper resource allocation management will require a greater number of resources for an attacker to mount a successful attack. Distributive allocation helps ensure that resources are properly distributed to handle workloads and provide availability. So in a cloud environment, quota management mechanisms are often used to control distributed resources. This mechanism tracks costs and keep budget allocations in check while also influencing performance and availability. Distributive allocation helps handle availability and avoid over or under provisions resource. When planning for distributive allocation, consider the three main things: design goals, traffic requirements, components configurations. Redundancy or fault tolerance. We will talk about this topic in next slide. So replication systems usually at multiple sites associated with the failure. So we move on next topic, high availability. High availability. So one way to increase availability or provide high availability is to use server clustering. Yes, server clustering is the combination of two or more so that they appear as a one. Clustering increase availability by ensuring that if a server is out of a commissions because of failure or planned downtime, another server is clustering takes over the workload. To provide load balancing to avoid functionality loss because of a directed attack meant to prevent valid access. Continuously planning might include a clustering solution that allow multiple modes to perform support while transparently acting as a single host to the user. High availability clustering might also be used to ensure that automation failure causes in case hardware failures renders the primary nodes incapable of providing normal services. So here this to ensure the high availability and reliability, the server redundancy is implemented. So this means the multiple servers are used to perform the same task. For example, if you have a web-based business with more than one server hosting your site, when one of the server crashes, the request can be redirected to other servers. These provide a high available websites. So if you don't host your own websites, confirm whether the vendor you are using provide a high availability and reliability. So cross-site replication might be included for high availability solutions that also require high levels of fault tolerance. In addition, individual server can be configured to allow for the continued functions of key service even in the case of hardware failure. So fault tolerance. The fault tolerance and the next topic is the fault tolerance. The ability of system sustains operations in the event of components failures. So first is the two key components: spare parts and electrical power protections. Such protections: uninterruptible power supply UPS, backups generator. So equipment will fail. So as one movie character has suggested, the world is an imperfection place. When a single driver crashes, sometimes the only a way to sustain operation is to have another copy of all the data. Redundancy and diversity are commonly applied principle for fault tolerance against accidentally fault. Fault tolerance allows a system to continue function even when one of the components has failed. Common fault tolerance solutions include RAID solutions which maintain duplicated data across multiple disks so that the loss of one disk doesn't causes the loss of data. So many of these solutions can also support hard swapping failed drivers and redundant power supply so that the replacement hardware can be installed without ever taking server offline. For risk mitigation, some redundancy and diversity control that can be implemented against the threat replication to different data center replication to different geographic areas, redundant components, replications, software systems, a distinct security zone, different administrative control, and different organizational control. So we move on next slides. RAID storage. So RAID storage, the most common approach to data availability and redundancy is a redundant array of inexpensive disk RAID. RAID organize multiple disks into a large high performance local disk. In other words, if you have 3 hard drive, you can configure them to look like one large drive. Disk array are created to stripe data across multiple disks and access them in parallel. Which are the main three things? Higher data transfer rate. The one is higher data rates on large data accesses. Second is higher input output rates on small data accesses. Third is uniform load balancing across all the disks. Large disk arrays are highly vulnerable to disk failures. To solve this problem, you can use redundancy in the form of error corrections codes to tolerate disk failures. With this method, a redundant disk array can retain data for much longer time than an unprotected single disk. With multiple disks and a RAID scheme, a system can stay up and running when a disk fails, as well as during the time a replacement disk is being installed and data is being restored. You can see on the picture, so RAID 1, RAID 0, RAID 1 and 6 or 5. So we're going to talk about the first four, the main the mostly used. The RAID 0 is a disk stripping. A RAID 0 implement a striped data array. The data is broken into blocks and each block is written to a separate disk drives. This requires a minimum of 2 disks to implement. RAID 1, mirroring and duplexing. This solution, called mirroring or duplexing, requires a minimum of 2 disks and offering 100% redundancy because all data is written to both disks. The difference between mirroring and duplexing is the number of controllers. Mirroring uses one controller, whereas duplexing uses one control for each disk. In RAID 1, disk usage is a 50%, the other 50% is for redundancy. So third is RAID 3. So RAID 3 is a disk, it's a parallel transfer with the parity. So in RAID 3, the data block is striped and written on the data disk. This requires a minimum of 3 drives to implement. In a parallel transfer with the parity, data is interleaved bitwise over the data disk, and a single parity disk is added to tolerate any single disk failure. RAID 5, disk stripe with parity. So meaning is independent data disk with the distributed parity block. In RAID 5, each entire block of the data and parity is striped. RAID 5 requires a minimum of 3 disks because it writes both the data and parity over all disks. It has the best small read large write performance of any redundancy disk array. So you can also Google it to 0 to 10. There is a 10 types of RAID level 1, level 2, level 3. So I just put it the main most used RAID for the environment, for the corporate environment. So when choosing a method of redundancy, opt for level of RAID that the operating system supports. Not all operating systems support all versions of RAID. For example, Microsoft Windows Server support RAID level 0, 1 and 5. In addition to hardware RAID, you can use software RAID. Software RAID is the best option when the expense of an additional drive is not included in the budget, or if the organization is using an older service. Software RAID can provide more flexibility, but it requires more CPU cycles and power to run. It operates a partitions by partitions basis and tends to be slightly more complicated. So another point to remember is that even though you set up the servers for redundancy, you must still back up your data. RAID doesn't protect you from multiple disk failure. So regular tape backups enables you to recover from data loss that result from error unrelated disk failure, such as human, hardware and software error. Exam question. Which risk mitigations techniques use a standard disk image for system restoration upon breach or failure? Answer A, master image. Answer is master image. That's it guys for this video. We will see more topics in later on video. please subscribe my channel. Please subscribe my channel. Press the bell button to get more update. Share the video if you like. Thank you so much. Have a good day.